Muted.
Good morning, everyone. Let's go ahead and get started. So what I plan to do is review the contents that we covered last time for Lab 1, talk about Lab 1 solution, then take you guys through the accounts that we need to create, and talk about the basic SQL statements so you all can work on Lab 2. That's basically the agenda for today. So last time we had started off with talking about Lab 1, and we were looking at database basics generally for the most part. So talking about why we need databases. We focused on the size of the database, most importantly, and introduced the idea of file databases, structured and unstructured databases. When I use the word structured and unstructured, I'm talking about basically relational and non-relational. When we deal with non-relational, we are looking at NoSQL. We're looking at NoSQL databases. And structured query language is useful with relational models for the most part. Relational model means creating links between files or tables in a relational database to enable referential integrity. Is everyone comfortable with the term referential integrity from last time? And if you are, tell me a couple of things that you may remember about referential integrity. And I'll give you hints. If you're inserting a record, deleting a record, or updating a record, it has to do with all three of these when we talk about referential integrity. Can anybody provide a okay, relationships are self-consistent and there is cross-checking. Very nice. There is consistency check to ensure when records are inserted or deleted, that relevant keys on which the relationship is built, values for these keys exist. And so cross-checking is something similar that one person in the room said. So cross-checking is, so Kai mentioned consistency check and David is mentioning cross-checking, which is basically to ensure that values exist. So if I'm trying to update a record, I'm trying to update a foreign key value, or if I'm trying to update a primary key value, and it has records in child table, then the update will fail. Can't delete something that should not be deleted. Can't update something duplicatively. Thus ensuring there are no mistakes by cross-checking. Yeah, nice, relevant descriptions of the referential integrity. As you can see, when we start dealing with the referential integrity, the explanations and words, we can be very clear But what I've often found, and I often like this, that when people are explaining things in, say, in an interview, if they take a data set and put something up and they explain, all three scenarios with a data set, things become much more clear and quicker to explain. So you can say that I have a table T1 with primary key and let's say column 1. And let's say we have table 2 with its primary key, column 1, and a foreign key that links to the primary key in table 1. Something like that. So now if I say I'm going to insert values in the first table, and then I'm going to insert values in the second table. And the foreign key that I'm referring to is obviously so to explain referential integrity, I can say I cannot update 1 because it has 2 rows in table C2. You see how the explanation changes? If I say I want to delete this entire row, I cannot do that, or I can if I say I'll delete these 2 rows too. So that's what referential integrity and cross-checking is referring and talking about. So, and these are some of the concepts that were asked of you folks in the first lab assignment. There was also a concept called data dictionary, which is basically a table or set of tables keeping information on the databases created. So data dictionary is also a small database of a sort. So that was lab 1, a light introduction, and I'm hoping you probably glanced through the Oracle architecture slide. You'll see the new video lectures appearing, and I'll just throw an old link to the old like this as time goes by. We need to, let's talk about the accounts that you all need. So you definitely need to create your Unix account, and in the email I sent you all yesterday, I included instructions on how to create the Unix account. So Unix account creation is, you can go to voyager.dienza.edu and you can find instructions for creating your Voyager account. And just follow this to the T, and it takes a few minutes to create. If you have trouble creating or accessing your Unix or your Voyager account, please email me and I'll get it resolved. So. And email me if you cannot access this Voyager account at any time. The next thing we want to focus on is your Oracle account. That was created yesterday, and email was sent. And I'm assuming you all have access to your Oracle login ID and password? Can most of you in the room respond to this with a yes or a no, please? I'd appreciate it if you can. Perfect. So let me quickly explain what the access refers to. So this is your home computer. And what happens is the database basically lives inside. Database lives inside this computer system. So what you have to do is, so this is all Voyager. This is the Voyager server. And what we do is we first need to have the Voyager account to access the server. And we basically have a secure tunnel over which we communicate. I guess I'm looking for like a bidirectional little picture, but this will have to do. So this tunnel is basically using secure. So this is your secure tunnel. And once you access Voyager, you basically log in with we log in with a utility called SQL Plus. And that gives us access to the database. And of course, database has its own files. So that's where the two accounts come in handy. You have your account number 1 here to access the server. And you have your account number 2 to access the database. So this account is the Voyager account. And this account is the database account that I shared with you. So, we don't allow you guys, because you're on a shared database, we do not allow, cannot access the file system from database. So that's the only limitation, but you can do everything else. Right? So I figured this picture would help you guys out a little. And I don't expect you all to know Unix to work with, don't need to know Unix. So a lot of times people say to me, why is this access so difficult, or why are we working with such a crude interface? You know, if you are able to work with the SQL interface, then we are game for pretty much anything. So the user-friendly interfaces are all out there, and working in the console to be able to retrieve data helps you practice and learn SQL really well. We are working with Oracle database, folks. So this database is an Oracle installation, Oracle 11G. So you're working with an enterprise scale database, and we're going to learn about its features as well. Now, to access the database, we have PuTTY as a tool, and instructions for usage. This is for Windows machine, by the way. The instructions for usage are at voyager.theanswer.edu, and I'll show you how to use it on this machine today as well. And for Mac users, you can just use the terminal window to access Voyager. So one thing I'm committed to is this week can get quite busy as a result. So what we will do is, if you guys need assistance one-on-one for accessing the database on your computer system, please send me an email to my personal account at singsubjit@fhpa.edu, and I will set up a web meeting and take you guys through it. It doesn't take more than like 5 minutes, and once you're comfortable with it, you'll be able to do your lab 2 and so on. So reach out earlier than later, and make sure you have access. And if for some reason your Unix account or Oracle account is not working, and we are resolving, and you're losing time because you have to start lab 2 and so on, I'll give you guys time, and I'm flexible with due dates just to make sure your accounts are set up and you're ready to go. So I just want to make sure you can still all hear me okay and can see the desktop. Your question, Vivian, on how can we access the database? You don't need your own server. That's why I was covering this information. You get an account on the Answer server called Voyager, and then you also have access to the shared database. So you guys will have, each one of you will have your own account and your own database to work with. So you don't need to set up your own database because, no, please don't even go in that direction. In terms of emailing, what I was suggesting is that if you have trouble accessing the Voyager account or accessing the database, if you want assistance one-on-one, I'm happy to set up time and help you guys out to get you guys started. So Kai, I hope that is helpful. So we'll go ahead and continue, and one thing I'm going to do is to log in, I need PuTTY. So I can just go ahead on Google somewhere and just type, I need PuTTY for this is for Windows, so I can just download this utility. I'll just get this 64-bit file, and when I start it, when I just click on it, this little interface comes up. Mac users don't need PuTTY, not at all. So, once I log in, I basically will. I hope you guys can all see this. I've got the host name and the port already set. If I click on open, it takes me to this window, login as. So Mac users can simply use the terminal window with the SSH command that I've provided, and they can go ahead and log in. So what I want to do is change this font size so you guys can all see. And so I'm going to log into my Voyager account first. And there you go. I'm logged into my Voyager account, and then I can just launch SQL Plus, right? And I'm going to type in my username. So I'm going to use SQL user 75, which is my own, and then the password. So now I'm logged into my SQL account, and I have to now set up my database to do my lab assignment. When you see the SQL prompt, that means you're logged in, right? So the first thing I'm going to go ahead and do is try to launch a command to see if I have any tables or not. So the one of the tables I'm going to work with is the employee table, EMP. So if I say describe EMP, semicolon, it says object does not exist, right? Obviously, I've just logged in with my default password, so I want to change my password. So I'll say alter user, SQL user 75, identified by my new password. So I don't know, whatever my new password should be. So 987654 and semicolon. So if I type this command can be used for changing your password. Okay, I'm not going to do that at this time. I'm just going to keep going. So now I'm basically at a point where I am ready to so the next thing I want to do is go ahead and set up my database. So to set up your database, you'll go to assignments, and we're going to look at assignment number 2. And it says run the following script to set up your database. So there is my window command, or my window for the database access, but I'll download this script, which is basically a text file. And the way this should work for all of you is when you open this file in whichever text editor on your computer system, you should be able to simply select all and copy the contents, and then go to your terminal or PuTTY window and simply right click. And that has set up my database. That's how easy it should be. Eventually you guys will learn how to write these kind of scripts. Eventually means before the end of this quarter, okay? So you can, if let's say for some reason in the end it doesn't say commit complete, or it shows messages that are, error messages and things like that, just make sure you have selected everything. So using Command A or Control A to select everything is very important. So select all again, and then you can come here and into the PuTTY window and simply right click, and lo and behold, it will do the same thing. Sorry, let me go ahead and copy that again. I think I'm messing up here. Yeah, there we go. So once the database is set up, you can do a check and say, okay, describe the employee table. And now it shows me the employee table in my SQL user account. Right? So what we have just talked about, folks, is accessing your user account and setting up the database. Are there any questions on this section of accounts? Sorry, I mean, some of you may be already savvy with Unix, and this might be a little slow start, but just wanted to be sure that everyone knows what the total architecture of the database is as you're accessing. provide you the relevant information to get started. Are everyone's questions answered? Or where can we find the initialization script? So Rashmi, you can find that under assignment 2, and you can see right here, it says run the following script. Kindly just click on that link and you can download it. Okay, now that we have done all this, let's talk about what we are going to do with this database, because that's the more exciting part. So that takes me to our next topic, which is demonstrating the usage of SQL statements to restrict and sort data. So working with SQL to restrict and sort data. So obviously we're going to work with one table. We're going to work with the select statement. And select statement has these 6 parts. So generally when we are writing SQL syntax, we put statements in, we put all the keywords in uppercase. But usually if you put everything in lowercase, it's not case sensitive, so you can use it like, even you don't have to follow the convention, but that's essentially the command. So now, how do we start with this process? Well, you've got your select statement first. And so we can say select from. This was the basic statement I had started you all with. Select star from EMP. So what this does is it's selecting all the columns in the table. Because when you do a describe, up above you can see that there are 8 columns. So the select star statement takes the entire column set and all the rows and brings it out. The reason why I'm bringing out all the rows is because I'm just not even specifying anything in the where clause to restrict the data. Okay? So if you're getting table or view does not exist, that means the database is not yet set up. So you need to run the initialization script, and then you'll be okay. And the setup issues, I would like to assist you guys one-on-one if that's okay. What does the 2 mean after you enter the command? Oh, these are just line numbers that SQL Plus generates, because what I did was I pasted this from the text window, right? So, Kyle, you have to run the initialization script, which is under lab 2. Like when you go to assignments, under assignment 2, there is this instruction right here that says run the following script. Please grab that and run, like I showed earlier. Okay, so we've got the basic statement. So if I want to just bring out certain columns, so you can see the column names. I can say select employee number, key name from EMP. So I'm selecting specific columns here. And there you have it. The two columns are selected. I can also, if I want to bring out unique rows, so this is again a gentle introduction to select statement. I can say select distinct. So let's first do this. Select Sal from EMP, and then we are going to run another command which is select distinct Sal from EMP. So all these commands, by the way, that I'm using, I'm going to post them for you in the notes so you guys can practice as well on your own. So you can see I've got 14 rows here. And do you guys see any duplicate values here? When you look at this data set, there are no duplicate values. Okay, so let me try this. Order by Sal. Because that's going to go ahead and sort the data. Now, do you see any duplicate values? It feels like an eye exam almost, right? So 3000 is duplicated, right? And 1250 is also duplicated. That's why sorting helps. So now what I'm going to do is, I'm going to say select distinct Sal. So please compare these two commands. We're going to say select distinct Sal from EMP. And then we'll say order by Sal. So what distinct is going to do is it's going to select this value 1 and the 3000 value 1. It's going to eliminate the duplicate. So let's go ahead and copy that. And for pasting, I'm just right clicking in Putty. So you see I got 12 rows. So if I want to give Sal a nice column header, I can say our low salary. And you see what happens? That puts a nice column header. Later on in the game, we are going to learn how we can, right now we are able to put about 11 rows per page. So each one of these lines indicates a page, right? So later on in the game, we're going to be able to control the size of the page, the width of the column, the formatting of these values. So we can generate beautiful reports. Because data analysts, that's what they're expected to do all day long, is produce reports that are readable. So you're going to learn how to do that. So let's say if I wanted this data in ascending order, right? So if I say order by Sal descending, so usually I tend to be lazy when I'm observing data. So the question that I asked you all earlier, well, guys, can you please tell me if there are any duplicate values, right? I just use order by because that makes life easy and so things become visible. Yeah, human eye is prone to error. So we can use commands to observe and look at data. And it's a really good idea, in my opinion, especially when you're working with SQL, when you're developing queries, to do so in a text file of your, text editor of your choice, and save your notes, because ideas develop. Sometimes if you want to go and explore and want to go back, you don't want to keep retyping the whole thing, because that's counterproductive. Okay, so today's lecture on the SQL part is so we can learn how to restrict data with the where clause. So we're going to look at all these arithmetic expressions, operators, and one big thing that is important to go over is the null value. And then, if we have time, we can go through group by and order by clause introduction. So again, guys, please keep in mind that this is the starting point, okay? And you have like 5 labs all on select statement or 4 labs that proceed that are all on the select statement. So if you do well in those 4 labs and then the midterm, you can go work as a data analyst with SQL comfortably, because you have got that basic skill at that point to go out and succeed in the in this subject. So the where clause is added to eliminate unwanted data from the query result set. So it's kind of a odd paradox, right? That we go in and we select all this data first, and then we say, I don't want some row. That's the where clause. So we go in and add data, or we add conditions in the where clause to say, I want to remove the data from the entire result. So if you have like 1 billion rows in a table, we go and tell SQL, bring me all the 1 billion rows, but I only want 2. And that's a lot of hard work the database has to do each time. But fortunately, the database engine is nicely optimized to handle that effectively for us. In the where clause, you can isolate 1 or more rows of table to modify. So, and we can also work with more than 1 table by joining the 2 tables. We're not going to look at the concept of join today, but that will be introduced down the road to you all, meaning next week. So where clause is used for identifying a condition. Here I'm saying, show me all the employees that have salary greater than 3,000. So let me go ahead and run this. And if we want to bring in equal to, then we'll get those 2 employees as well that have the salary of 3,000. So you see, whenever I put something in the where clause, I always like to look at the values as well, right? So I will look at this data set. There are only 3 employees now that come up. If I don't have the where clause, I'm going to get 14 rows. And if I want to look at this data in descending order, you all know what to do. You basically say order by descending. And there we have it. So when I see something like this, that this means something was in the buffer or I did not type, it did not paste properly. So then you retry. Oh, order by Sal descending. I forgot the column name. That's why it was complaining. Right? Or if you want the data ascending, then you can say that. Having fun so far, folks? Everyone awake with me, can hear me and can see the desktop? So a lot of questions. Okay, wonderful. A couple of you answering that helps me just know that I'm still live with you guys. So here is where we look at the where clause. I'm not going to go through this today, but this is demonstrating. When I say I won't go through this today, I mean I'm not going to show running examples. But what we're trying to do here is select a bunch of columns from two tables. So what this does is it creates a Cartesian product. So where clause can be then applied here to combine data from multiple tables. Combine data from multiple tables. So, sorry, what about column numbers? If you can please express that question in detail, I'll be glad to answer it. I did not understand the question. So, in the notes, we have this idea of, or in the PowerPoint, we're saying select e-name, salary, department number. So I'll say D dot department number and E dot department number from EMPE, comma, department C. These numbers are not column numbers, these are line numbers. So I have 4 lines that I pasted when I did a right click. So 2, 3, and 4 are just line numbers. So you can ignore those. Those won't appear if you hand type the command using the enter key. So, but I'm lazy, I like to type it in Notepad and right click and just use it. It's more effective. So I'm trying to select from 2 tables. I've got employee table with E, and I've got department, which I'm naming as D. These are aliases that I'm choosing. And what I'm saying is, I want to bring in columns from I want to bring in the department number column from the department table, and I want to bring in the department number column from the employee table. And what this slide is telling you is that this is going to create a Cartesian product. So if one table has 100 rows and another table has 10 rows, the result will contain 1,000 rows, basically a Cartesian product. So I want to show you guys the number of rows in each of the tables we are about to. So let's do this. Let's say count the number of rows in employee table. And let's count the number of rows in department table. And then let's also describe the department table so you guys can see what that looks like. let's also describe the employee table so you guys can see what that is, right? So these are commands that you will get used to by practicing. So if I say this, it tells me I have 14 rows. And if I run the second command, it tells me I have 4 rows. So Cartesian product will have 48 rows. So if I describe the department table, you all can see it has department number, name, and location. If I describe the employee table, which I've done a couple of times already, it has 8 columns. So you see, now I'm going in and I'm doing this Cartesian product and selecting employee name, salary, and department number. It just so happens there is department number in the department table too. So we run this. Oh wow, we get 46 rows. 56 rows, excuse me. I messed up in my math earlier. 14 times 4 is 56, right? I might have said 48 for some silly reason. So that's the Cartesian product. You see, so now you can look at King and how this data repeats. You know, we've got, when we look at D dot department number and E dot department number, you should observe this data set. So what I'll do is take this entire test run. So this is something also you guys will have to do, right? When you're submitting your assignment, you can select and then just paste the answer in, or paste the result in your text pad. So I'm just going to write a note for you all here and move to the next slide and say, please review the Cartesian product results and observe the data set relation. And that will have a revelation for you all, which we'll cover on next Tuesday. Cartesian product. I mean, I may have mentioned that set theory is used in SQL a lot. And so getting to know the set theory is a good idea. So we'll go through that also. If you search my page, you'll see that in the very bottom. So we can add more than one condition. This is not very interesting. It's trying to show that we can write more than one condition, but you know, let's put together something that's a little bit more interesting. So we're going to work with one table, right? So I would like you all to come up with an idea for come up with an idea, folks, for using more than one condition. And you're obviously looking at the employee table, and you know all the columns. So I'll select some columns while you guys are thinking of an idea for me to apply to conditions. And as you can see, I'm always interested in people's salaries. So employee number, employee name, salary, manager, and let's say when they were hired. And I'm now ready for two conditions. What two conditions I should write here? Any ideas? You're looking at the employee table. I want to use two conditions in my select statement. So what I'm saying is, well, let's bring in all employees to get the juices flowing here on ideas. all the employees who have salary greater than, say, 1,000 and work in department number 10. Oh, and hire date is greater than January 2010. Yeah, we can do that too. So we can write these two conditions, right? So the way the conditions are written are we use relational operators. All these are the relational operators that we use. So this is the equality operator, not equal to, greater than, equal to, less than, equal to, greater than, and less than, right? So when this query is processed, let me first run it, right? And I like to use brackets for clarity. So that will show us all the, that will show us all the employees that have salary more than 1,000 and are working in department 10. See, one thing with this query is I did not select the department number. So now how is this query processed? And a lot of the SQL, a lot of the data analysts out there say, well, I write the code, the database does its job, and I'm done. And I don't really care about how the database processes it. Well, that's where the failure happens, because if your queries are slow and you don't understand the inner workings of the database, then you cannot optimize the query. So in this course, we're going to take a little bit of effort in focusing on this particular subject. So the database is going to select all row IDs pertaining to the M tables. So meaning it selects 14 rows. Then it applies condition 1 and selects all row IDs pertaining to that condition. So, you know, how many employees have salary greater than 1,000? So we can write another query to see that. So we can say select star from EMP where salary is greater than 1,000. So those are 12 rows. Is everyone following so far? Then I'm going to apply condition 2 and select all row, and then it will select all the row IDs pertaining to that condition. Now I don't know how many employees there are in department 10, so I can just run another query and say three. So you see, out of the 14 rows, when I end up applying these conditions, it's applying with the AND operator, it's applying the intersection concept of set theory. So it takes the 12 rows for the first condition. It takes the 3 rows for the second condition. And because we used an AND operator, it applies the intersection and gives me the 3 rows where both conditions are met. Are you guys familiar with the concept of union and intersection in set theory? And if you need a refresher, kindly look at my notes. We are going to be looking at that in lab 6 down the road. But if you need to kindly review, please look at this one. Here, let me take you to the website so I can just point out which one it is so you guys can review it. On this page, if you just search for the word set, you'll find it. Learn the basics of set theory. So I link you to this Wikipedia article, and you can just spend the time to look through some of this. Okay. So learning how the query is processed logically and then from the system standpoint, we're going to focus on both of those ideas as we go through this course. Okay, so working with 2 conditions. So conditions in the web clause can be comprised of several operators, and it can also include expressions, like all these expressions with numbers, column names, literal values, functions, and subqueries. And then we have all these different operators that you're going to be exposed to. So let's go through these. So here is an example of an expression used in the where clause. Using an equality. This is a conditional logic. Somebody was asking me earlier, why is the equality not a double equal to, like a double equality operator in SQL? Well, it's hard to answer that question because I did not create SQL. So, but that's how it is. You know, back in the day, this was 1980s when this was created. So the equality operator and the assignment operator are used interchangeably depending on how they are used. What this does is it sets the salary to 3,000. So that right here is an assignment operator, where equal is being used as an assignment operator, and here equality is being used as a comparison operator. So it says for employee 7566, set the salary to 3,000. Question, does it make sense in large databases to list So when working with large DBs, does it make sense to list where statements that return smallest number of rows first in order to enhance performance? No, that is all relative, and you have to take the query processing, query by query, and you also have to just look at the sequence of queries, the frequency of usage, and so there are so many other factors. So approaching the topic of query performance is a complex one, and we will take strides in small units as you go through this course and others. Here is an update statement with a select statement. So we can go in and say, where employee number equal to, and then we find the employee number using a subquery. I hope your question was answered, David. It's a really good question, but unfortunately, query performance is just doesn't have a short answer, as you may know. There are many things that will go in, and so we'll come back and answer this particular question multiple times. But returning smallest number of rows first is not really going to have a impact on the database performance, to give a short answer. So then we have arithmetic operators. We're all familiar with these. These apply to both number and date data types and generally used for calculations. Here's an example of the usage of an arithmetic operator. So it's applied that, let's take the value of one of the expression, add some value to it, and use it in a condition. I would encourage you to kindly spend time writing your own queries, as I was earlier, and running them for each one of these slides. So in this particular slide, if you have to practice with the actual values, just use the sal column. Because I don't think there's a low sal column in the employee table. So the slide was a little redundant. There is operator precedence, multiplication and division taking precedence over addition, subtraction. And operators that have the same precedence are evaluated from left to right. And I like to use parentheses to have more control over enforcing priority. Then we have these 5 different types of operators. So comparison operator, the single equality appears again, and then you have the rest. And we also have a null operator that is used for columns that have null values. It's used with columns that have null values. And we have multiple row operators like in, any, and all, and we'll go through those separately in time. So here is the not equal to operator. Please take note of that. I think I may have said this earlier, or not equal to, which was wrong. It should be this. So we are applying relational operators, and we have seen examples of that earlier. So I'll not spend time on this since I've shown you a couple of examples. Is-null operator is applied with columns that can have null value. Null value basically means the value is unavailable and unassigned, and it cannot be compared using an equality operator. So if I run this, so if I say select distinct emp number, sal, and commission from EMP where commission is not. So let me paste this in your notes so you all have it for running later. And we look at this. So you can see all the employees that don't have any commission. Now, if I were to rewrite this query and I was to say commission is equal to null, you'll notice the behavior, it is no row selected. So this really doesn't work. So that's why you got to use the is null operator to get the value results. All right. So in this represents like selecting the values from the data set. So as long as the employee name is in those two values, we can set. And then here we are using the equality. Here we are using other relational operators. If salary is greater than any of these, and salary is greater than all of these, then we have string concatenation operator. So if we are trying to combine two strings, we use these two vertical bars to concatenate. So to demonstrate running this particular query, sometimes special characters from PowerPoint can get in the way. So what this is doing is concatenating two operators, two columns, and then providing a column header. That would be string concatenation. And this is kind of how it works. So what got in our way was these operators, these characters were misrepresented in PowerPoint. So you have to factor that in when you copy and paste code from PowerPoint and use it. Matching operators. So we have this like operator that does character matching. So here we say that we want to select all employees whose name starts with the letter J. Now keep in mind, every time you use the percent sign, that's a wildcard. So it will match all characters starting with J and after. So if there was a person named Joe, 3 letters in the name, that person's name would also be selected as a result of this condition. I want to make a point here that is going to be useful in lab 2. When you look at the e-name column is of type char, which is a fixed length. So what that means is if we put a name like Joe or James, it's going to use 10 spaces. For Joe, it should actually use 3, or we can use, for James, we should use 5, but that's not the case. When you have a column that is fixed length, you've got a total of 10 spaces that are used for all names. So for names like Joe and James, we're going to have trailing spaces. So when we are doing comparisons, what I like to do for queries like this is the following. I would always, in the where clause, apply a trim function. That way, I get rid of leading or trailing spaces before doing the comparison. So please keep that in mind when you're doing. I mean, the query will still work, and watch out for the single quotes, please. Okay, it still works, but getting rid of those trailing spaces is going to be a useful idea in your lab assignment. We don't use the star wildcard. We use the % wildcard with string. Because star is being used for selecting columns. If you want to match one character, then you can just use an underscore. If you want to match one character, you can just use an underscore. And if you want to match % or underscore, then you have to escape those. So like if I have a department named accounting _1, then what I end up doing is I end up using a backslash and then the underscore, and then I have to specify what my escape character is. If my escape character is a question mark, then I can do this, and that would still work as well. But conventionally, we end up using a backslash for the escape character. So we also have the and or not operators, which again, when I was going through query processing, I explained how the and operator would work. So for and, both conditions would be true, and I would use brackets to set precedence. For operate or operator, only one condition has to be true. And you guys should come up with some scenarios to practice, right? Some real world things. Maybe on Piazza, I can throw some ideas for you all to practice. And we can maybe collaborate on those just for fun. No extra credit, right? Not operator will inverse the condition. So if we were to say in, we would say 2040, but when we say not in, then it gives other department number. Here are the rules for precedence, for the not, and then or. But parentheses override everything. And so I have a couple of slides on how the and or operators are used, so you can review those for fun later. Finally, we have the in operator that we have talked about, and we also have between. Between talks about, it's inclusive. So you provide a value range, and it works with both the number and the date data type. It works with both the number and the date data type. The rest of the slides follow up on null values, and I'll cover the concept of null values on next Tuesday. But I wanted to spend a few minutes on the assignment. So, just talking about each question and giving you guys some hints. So after you have ran the script, you have to write a few queries to submit. So the best way to submit this would be you write the query for each question, run it, copy and paste the output below, and submit one text file with your SQL queries and the result. So question 1. This is lab 2. I use the word lab and assignment or project interchangeably. So we write a simple query to show all these columns from the employee table. Then once you have written that select statement, you modify to display all the columns in the employee table. And then use the where clause to restrict. Well, employees with the same name don't appear twice. So that's the usage of distinct, if you know what I mean. Then the second one says practice with the insert statement. And you guys know where you can find the answer to this, right? Anybody? Got a hint for this? Where can you find the answer to this question? Yeah, previous notes is there. But the script that you're going to run has insert statements in the employee table. Very nice, yeah. So you can learn from that and apply. I wouldn't say that is copying, but it is. Oops, I went on the record saying that. Sorry. That's how we learn. So show how you will modify a record. So go back and look at the update statement and make a change. Then write a SQL statement to show this information. Number of employees with 2 L's. That means if employees have the name Alan, so L is next to each other, or another name where L might be between, might have other characters in between. If somebody's name was Loyal, L-O-Y-A-L, you should be able to select that too. So that's 2L. It was the initialization script. Your question is how do you access the file I just showed? The M file was that initialization script I showed earlier that you run for setting up your database. Once you have written this query, you update it so the names have to start with the letter N. I don't have to have data set for these queries to work, right? So you can write the queries and you can also create your own data. So you feel free to add insert statements or add records using the insert statement. The next one says display all employees, display all fields in the department table where location is Boston. That's an easy one, right? You can just describe the department table and select the column. This one gets a little, like this is a little, you have to think about this a little bit. Employee who is not a manager and is not a clerk in department number 10. So I'm giving you this question to use and conditions and or conditions. These are the kind of ideas we should come up with on Piazza so you guys can practice. right? Does everyone have an invitation to the discussion board already? If I can get a response, okay, perfect. And if you don't have access, please let me know, and I will be glad to give you the access. But everyone that is registered as of Monday morning, I've given access to, because class list was, I think, well settled by then. The next question is using the between operator. Because, you know, we've got the word between right here, right? So, doesn't take very much. And then we have a SQL statement to show employees who do not have any managers. Another SQL statement to show whose managers have employee IDs 7566 and 7788. Are you going to use an OR operator here or an AND operator? You decide. Most likely, an OR operator would work. That's your assignment number 2. What we did not talk about today is null values, which is the last few slides. And we should go over that next time. But regardless, I would urge you guys to read these slides, because it talks about why null values are created and in the database, and what's the value proposition of the usage. That is all I have for today. If you guys have any questions, let me know. Otherwise, I'll see you guys same time, same place. Have a wonderful rest of the week. Stay in touch with the class by posting questions on the discussion board. You should get the textbook. Those are references. So you can wait and see if you need it or not. You can't find the initialization text file. So you go to assignment 2 page and you go look at the link that says run the following script. Do you see that? That's where it is. Okay. In a work setting, you'll most likely use a GUI tool. In the class setting, I'm trying to have you learn SQL, so you don't use the GUI tool to generate SQL queries. Then you want to learn how to work with, you know, SQL, which is my main purpose in the course, right? And if you have found a free version of the textbook, you can post that on the on Piazza, and I think people will like that. Thank you, Vivian. Any others? Any other questions? Great. Awesome, folks. Stay in touch. Have a wonderful week. Bye, everyone.